In examples 1 and 2, we want to verify these trigonometric identities. When you verify, you're only supposed to work on one side of the equal sign. You can kind of work on the other, but you got to erase what you did. Let's try to work on one side only with example 1 and 2. The first thing that I look at is I try to see which side is more complicated than the other, and then maybe I can simplify this and link it back to the other one a little bit easier. So it looks to me like this left side is a little more complicated than this right side. We're going to try that old trick, which is to, or old method I should say, which is to change everything into sines and cosines. You'll notice how the cosines will cancel and we'll be left with sine of theta, which is equal now to the right side. So this trigonometric identity is verified. For these types of problems, the work is the solution. You're supposed to get the left side to equal the right side. If you just wrote down sine of theta equals sine of theta, well, good for you, but it's actually this work that we're looking for. The one on the right hand side is a little more complicated. If we look at example 2, the left side is just the tangent of x, and then the right side is pretty complicated. So let's try to work on the right side. You're going to need an eraser with these, and just so you know, when I'm doing these problems, I have a little cheat sheet over on my left hand side, and I've tried these problems several times, and it might take even 15 or 20 minutes just to get one done. I'll have to erase, go back, and then try something else. So what you're seeing is the polished version. Please don't think that they're as easy as just writing some work down and calling it good. The only way to work these problems is to practice lots of them and then also to persevere when you solve them, so don't give up. Right away though, with this one I'm seeing that I've got a tangent squared plus 1. And I'm wondering if that's one of my Pythagorean identities. If you look at your trigonometric identities toolkit, you should see that 1 plus the tangent squared is equal to the secant squared. So I'm going to change that out and see if that helps us. I am allowed to cancel one of the secants with one of the secants down here. Secant squared is the same as secant times secant. So I'll be left with one secant in the numerator. One secant and one secant will cancel out. So I'll be left with a cosecant of x here. The next thing I think I'm going to try to do is I'm going to try to change everything into sines and cosines. So the secant of x is 1 over the cosine, and the cosecant is 1 over the sine. If we continue with this example, 1 over the cosine times the reciprocal of 1 over sine x, which is sine x over 1, is how we could change this complex fraction into just multiplication. You'll notice then that the sine of x over cosine of x is totally the tangent of x. So some of these take a little while to do. They're a little bit long in nature. And remember that we started with the tangent of x. I know that's hard to see, but here you go. So the tangent of x was on the left hand side. And then if you look at the right hand side, we now have the exact same as the left hand side. So this trigonometric identity is verified. Once again, you are seeing the polished version of this. You could do something different here, and you might wind up verifying this in a different way, and that's fine, as long as it's algebraic and you're going to have to try these several times.